Hello students, welcome to class 11 physics. In this video we are going to solve textbook illustration of chapter number 5 laws of motion. So illustration number 11. A circular racetrack of radius 300 meter is banked at an angle of 15 degree. If the coefficient of the friction between the wheels of race car and the road is 0.2, what is the optimum speed of the race car to avoid wear and tear of its tires and maximum permissible speed to avoid slipping? That means here we need to find the optimum speed as well as the maximum permissible speed, that is Vmax. Here we are given theta equals to 15 degree and mu equals to 0.2. We know for the banked road, the optimum speed, that is V0 equals to under root Rg tan theta. Here radius is given as 300 meter. So 300 into G is 9.8, tan 15 degree. Value of tan 15 degree, that is 0.2679. So when we calculate this value, we get 787.626. So under root of 787.626, that gives 28.0646. So the optimum speed is equivalent to 28.1 meter per second. Now the maximum safe speed. The maximum safe speed, that is equals to under root Rg into mu s plus tan theta upon 1 minus mu s tan theta. So substituting the values of R, G, mu s and theta, we get it as 300 into 9.8 into 0.2 plus tan 15 degree upon 1 minus 0.2 into tan 15 degree. Tan 15 degree is its value is 0.2679. So when we calculate this, we get these as under root of 2940 into 0.4942. So its value is 38.1256 meter per second. When we round off this, we can write it as 38.1 meter per second. So maximum permissible speed, so that the car driver does not slip, the car does not slip, it is 38.1 meter per second. This is the maximum permissible speed. So student, you may note down this numerical. Now numerical number 5.12. A wooden block of mass 2 kg rests on a soft horizontal floor. When an iron cylinder of mass 25 kg is placed on top of the block, the floor yields steadily and the block and the cylinder together go down with an acceleration of 0.1 meter per second square. What is the action of the block on the floor before and after the floor yields? Take G equals to 10 meter per second square. Identify the action-reaction pairs in the problem. So first we will be seeing the action of the block on the floor before placing the cylinder of mass 25 kg on it. So let us see here. Let us see the free body diagram. On the horizontal surface there is a block. So its mass is 2 kg. So two types of forces will be acting on that. One is the weight, that is in downward direction, W equals to mg. Mass of the block is 2. G we need to take here 2, that is G we need to take it as 10, so we get it as 20 Newton. So in the downward direction the weight is 20 Newton, and in the upward direction there is the normal force or the reaction which is normal to the surface. So here, let us see the first case. At floor, block is stationary and its free diagram is shown in figure. Forces acting on the block are weight, that is the gravitational force, and the normal force are, and by Newton's third law, R equals to 20 Newton in upward direction. Because here from the free body diagram we can write W equals to R. That is R equals to value of W, that is 20 Newton. So R equals to 20 Newton in upward direction. Now when the system, that is the block plus cylinder, moves in downward direction and acceleration with acceleration of 0.1 meter per second square. So here as you can see, on the top of the block there is a cylinder placed on it. So what happens? This whole system comes downward in downward direction with the acceleration 0.1 meter per second square. So the forces that is acting is weight in the downward direction. Here we can write weight equals to mass system, that is mass of the block plus mass of the cylinder into G, that is 2 plus 25 into 10, which is equals to 270. So 270 Newton in downward direction, and R dash, that is the reaction or the normal force in the upward direction. This is the free body diagram for the second case. So let us see the second case. Forces acting will be as follows. The gravitational force that we have seen, that is the weight in downward direction, 25 plus 2 into G, that is 270 Newton in downward direction. And the normal reaction by the floor, that is in upward direction. Now when we neglect the force, when we neglect the internal force between the cylinder and the block, what we get is as the total force F is equals to the weight that is in downward direction and reaction that is in upward direction. So we can write W minus R dash. So here F is equals to M into A. So we can write taking R dash in on left hand side, so it becomes positive. R dash is equals to W minus capital M A. Here M, that is the mass of the system containing the block and the cylinder. Here weight we got as 270 minus total mass, that is 27. Acceleration is 0.1 meter per second square. So here we get 270 minus 2.7. So value we get it as 267.3 Newton. So here R dash is equals to 267.3 Newton, which is in downward direction. Action reaction pairs. See, for the first case, when there is only block on the floor. First, the force of gravity on the block by the earth, that is action, and the force of the gravity on the earth by the block, that is reaction, which is equal to 20 Newton directed upwards. Second, the force on the floor by the block action, the force on the block by the floor reaction. Now for second case, the force of gravity 270 Newton on the system by the earth, the force of gravity on the earth by the system, that is reaction, which is equal to 270 Newton directed upwards. The force on the floor by the system is action and the force on the system by the floor is reaction. In addition, for the second case, that is B, the force on the block by the cylinder and the force on the cylinder by the block also constitutes an action-reaction pair. So students, you may copy down this numerical.